Now we're going to continue on with chapter 14 and do the second portion of it. We've been talking about indirect, direct attack, and structure fires. And we're going to start back up with fires in upper levels of structures. And we'll start with structures without standpipes. Your fire attack may include moving up the stairway that is closest to the fire. Always check for fire extension before advancing up the stairs. More personnel are required for this operation, and we need to remember that stairways can be dangerous situations. Your standpipe location will determine your fire attack method. In unprotected locations, your hose line is connected on the floor below the fire floor. In a protected stairway, hose lines may be connected on the fire floor. And in our protected stairways, this gives you the option of flaking out less hose. You're going to use less hose and make things a lot faster. In our unprotected locations where you have to connect a floor below, you're flaking out more hose. It takes more firefighters and it takes more time to execute your hose lay. And in these situations, certainly this is something that we need to practice on a regular basis. Once or twice a year is something, this is a skill that needs to be practiced so everybody is clear on how to deploy the fire hose in these situations. This can require, again, large numbers of personnel depending on what you have to do. This means that firefighters must carry additional tools. We already weigh your gear plus your weight. You're adding 75 pounds to whatever you weigh, and then the more gear or hose that we have to carry, we're certainly adding more weight. Elevators cannot be used to transport crews to the fire floor itself. You can utilize elevators in multi-story buildings, but you need to be cautious in doing so. You can transport equipment and firefighters, putting them in fire service mode, but you're not going to take that to the fire floor. You're going to go a couple floors below the fire floor as an example, if that elevator is usable, and then you're going to advance from that point. And there may be situations where all of the elevators have recalled because smoke in the hoistways, and that means that we're not going to be able to use them at all. Exercise caution in streets around the perimeter of the building as well. Residential and basement fires. Uses of basements. Basements are used for a lot of different things. They can be used as finished out and used as living quarters, which we find in a lot of cases where you have family rooms, TV rooms, even bedrooms and other living quarters in the basement. Entertainment rooms, man cave, or theater room and system. A lot of folks will finish their basements out for this type of use, or even have game rooms and that kind of thing as well. They can be used for utility spaces. Some people will put together a woodworking shop or some type of shop in their basement to where they can work on hobbies and other things. Some basements have what is known as a drive out, and they'll install garage doors or overhead doors, and they are typically used as a garage. So people would park vehicles in the garage and then would ascend the stairways to the first floor, so on and so forth. So this is also a common practice. And in some basements, they're set up as storm shelters. My basement is set up as a storm shelter. There's a vault underneath my porch, and it is accessible to be used in the case of a tornado. Unfinished basements. In our residential homes, the first floor joists are exposed to the fire and can fail sooner than a ceiling that would be protected by drywall or with drywall. Right now, in my house, it is unfinished. Some people will go ahead and put sheetrock or drywall onto the ceiling and cover it with a 5/8 thicker sheetrock, and this would certainly keep this from happening, or extends that period of time, if you will. Generally unoccupied, so fire may spread before it is found. I will say, in modern residential construction, the building codes have changed a little bit, and you are required to have smoke detectors above and below, your stairs. So in my basement, I do have a single smoke detector at the bottom of the stairway, as well as there's one found at the top of the stairway, close to that opening. So, um, but we got to realize that my house is new, and there are plenty of old houses out there that have not been retrofitted with smoke detectors in the correct places, or maybe they're battery operated only and they've not been upgraded. The hazard of collapse during fires a lot can cause this. Some of the things that have to do with it are fuel loading is one, the age of the exposed joist is another, how it was constructed, whether it was used beam technology like I-beam and lightweight truss construction type materials, or was it just done with regular dimensional lumber type joists? And also the hidden paths for fire to travel and ducts in walls and that kind of thing. Converted basements create life safety hazards. Owners and occupants may not comply with the regulations when they do this. A lot of times the basement will, in the initial construction phase, will not be finished, and then later on folks will go back and finish their basement, and sometimes owners and occupants do not get proper building permits. They'll go ahead and do this on their own type thing. Maybe they're doing their own electric, they're doing their own sheeting with drywall and things like that. And so what we don't know is, was it done to code and properly? Some people do hire contractors to complete this process and certainly would fall within, the parameters of meeting the building construction codes and guidelines. When I will say that when you get your occupancy certificate at the end of the game and you didn't finish your basement, it's noted that it's unfinished, but again, you're allowed to dwell and live there, and the things you bring in and the projects that you do, really nobody has any knowledge of but you or your family. So it'd be pretty easy to convert a basement. And in doing so and not following the correct guidelines, you could create safety hazards. With residential basements, the initial size up is essential. Floor assemblies can reach a point of collapse before firefighters arrive. Joists can collapse before the floor decking. Firefighters working above a basement fire are at increased risk of collapse. We should verify that the floor above the basement is there. And so that's when, anytime that we enter a residence, you begin with sounding the floor as you advance. So if you're crab crawling, and even if you're standing up walking in some situations where there's not high heat and a lot of smoke, as you step, sound that floor to make sure that that assembly is intact. You can have basement fires that go into a smoldering phase and they have burned out certain areas of the floor, as an example, and weaken that. And when you add, a weight of 2, 3 firefighters and a hose line, you can collapse through it. Again, basement fires can weaken the main floor and create a constant danger of the collapse of the floor. Thermal imagers will not always provide an accurate assessment of the integrity of the structure of the floor system. Remember that thermal imaging cameras, they are great tools, but they show the difference in between temperature of what you're looking at. So it's either cooler than the air is cooler than the object, as an example. So it's showing you temperature and the difference in the temperature of those things. With residential basements, access, interior, enclosed stairwells, a lot of times is the only access. Sometimes you may have exterior enclosed stairwells with them. You may have exterior open stairwells, and you may also have window wells, or a half window well, if you will. Ground level walk-in doors or windows may be present as well, or even walk-out overhead doors. Using interior stairs for your fire attack is a dangerous prospect. Alternate entrances should be communicated and used if at all possible. Interior and exterior enclosed stairwells can act as flow paths. Again, we have to remember when we're opening these areas up that we possibly could create a flow path or connect that and create that, and we have to be cognizant of that. Advancing hose lines down interior stairwells may be the only avenue available, and in doing so we must be quick when we're doing that. You need more personnel and you need to communicate well. Wide nozzle pattern may be needed for protection. Accessing the basement must be coordinated with ventilation. Exterior attack can be made through the basement windows. You may use openings to apply water before ventilating or entering the first floor. Penetrating type nozzles or a cellar nozzle can also be used. In order to use those type of nozzles, you'll have to make a hole or pierce a hole in the above decking and the flooring to use them. With a cellar nozzle, you'll have to cut a hole and drop that nozzle and operate that. They operate at a lower pressure, but they will spin basically water patterns down through the hole into the opening or the area that you need it. Reduce the amount of fire and make another assessment of the condition of the basement. So we can darken it down, then do we make a decision to go down that stairwell? Is it more tenable? But we do have to realize has fire damaged the stairwell? And remember that it is a dangerous prospect either way. If you choose to go down the stairs and that's your only other method, make sure you sound the stairs as you go down. You need to the first person needs to get down, communicate that they're down, and if there's any obstacles in the way. Once everybody is down, they can begin the process of extinguishment or finding the fire. Have enough hose line to do so. Typically in most residents, we want the first 50 in immediately. If it does take another 50, then you can coil up your hose and get that second 50 in. A ventilation limited fire, the ventilation increases the heat release rate, and this may result in flashover. And it can be fatal to firefighters on the stairs or in the basement. We do have to understand if we complete that path and we let a ventilated or ventilation limited fire have enough air that we can, at that point, we can create a lot more heat. Fire can kick up and can cause flashover. The conditions may be untenable even if flashover has not occurred yet. It may be very hot. If you're crawling along or you're crab crawling and advancing along and you feel like that you have to get your gear off of you, that your gear's already saturated with that heat to the point where it's beginning to transfer to your body, it's hot and you need to cool the environment. Opening a vent point will create more problems unless it is coordinated with your application of your water. So again, as we have talked about with tactical ventilation, we need to ensure that this is timed correctly. Commercial basements and subfloors. The construction may be similar to residential basements, or it could be more robust, such as concrete. Older Type 3 construction, your first floor joist may be exposed wood or even made of heavy timber. Modern structures, the floor may be exposed or unexposed concrete panel or a metal C-type joist. Some structures have multiple subfloors. Some standpipe connections are in the stairwells leading to subfloors. We need to do a risk-benefit analysis It's the same as for a residential basement fire. Pre-incident plans and surveys and inspections will help determine the type of ceiling construction and the amount of fire that can withstand. Your tactics may be influenced by the location of your standpipe connections, the potential ventilation flow paths, and the amount of breathing air needed to access the fire. In larger commercial structures, we have to realize that um, we could be in large, open, bigger spaces, and therefore it may take us more time to get to where we're going to extinguish or find a fire. So we have to leave ourselves enough air and think about our air management a little more closely. Exposure protection is preventing fire from spreading to exposures, and this can be inside exposures, unaffected areas, or adjacent rooms and compartments inside the building as well as outside the building, which could be adjacent structures and buildings outside that may be nearby. The type of protection will depend on the location, the type of exposure that it is, and the available resources that we have. Exposures that are on the interior, we can help protect these better by simply closing doors and openings and not allowing heat, smoke, and fire to travel. Uh, we can use proper ventilation, whether that be vertical or horizontal as well, and fire-related walls and doors. You know, if they're rated good and we close doors, if we have breaks, uh, then we can also utilize that to our advantage. Exterior exposures, we want to remove endangered persons, property, or items. We may apply water or Class A foams to help protect and pre-protect. Keep those, basically, the foam, Class A or Type A foam will stick to the outside of these structures and buildings and even vegetation, and it remains foamed for a period of time. And when the foam dissolves away, it releases the water that's in it, and it will continue at that point to protect until it evaporates. So you get a good amount of time of protection. We may consider relocating parked vehicles or railroad cars as well, moving piled storage, or even relocating our fire apparatus. Foam, again, are our Class A foams we use as a pre-treat. This foam it kind of sticks to what we're spraying it on, whether that be vegetation or a structure, and it will hang out there for a period of time. Again, when the foam breaks down, it releases the water in it at that point and will continue to protect until the water evaporates away. Water is, it will cool and evaporate. Next, we're going to explain the role of firefighters with regards to the support of fire protection systems during fire suppression. Supporting fire protection systems we often term as either standpipes or automatically sprinkler systems, automatic ones. These work with systems to control the fire. Do not discontinue the use of your system before the fire is under control or the incident command gives you the shutdown order. These systems are designed to suppress. They work very well. They put out a heck of a lot more water than you think, but we still need to have things under control before we shut them down. Believe me, they're helping us out greatly, but sometimes when occupants store things and store materials too close to them, they suppress but they don't do full potential. We still need to get in there, overhaul, and fully put out the rest of the fire. Only intended to control fire's growth and prevent flashover is the sprinklers. That's their design, and that's how they are put into work. Complete suppression again before turning them off or deactivating the system. Systems that are active should not be discontinued before again, the fire is under control. When we connecting to our FDC or fire department connection, basically our pumpers will supplement the water supply and pressure to the sprinkler or standpipe system inlet. These should be labeled for the building and the zone that it services, and it should have a setup to where it's easily connected. It should have caps on where they're protecting what's inside there, and certainly when we uncap them to hook up, look and check for debris. Closing your main control valve. This is located between the sprinkler system and the main water supply. It does shut down water supply to the entire system. Some are designed with sectional valves to shut down smaller areas or individual sprinklers. You can block off certain areas in these larger systems. You do have to know where the valves are. You may need somebody, if this is not written in the pre-plan, you may need somebody that knows the building, such as maintenance, that can direct you where these different valves are. You can shut a section down basically, but keep the rest of the system active. And these are secured in the open position and oftentimes are electronically supervised. So they're locked open and they have an electronic circuit that if the valve were closed, it does communicate that to the control system and the alarm system, and it will alarm to let you know it's been shut down. Closing the main valve should only be done once the fire again is under control and the incident commander gives that order. Some jurisdictions maintain or protect the scene until a qualified technician arrives on scene and then can bring the system back to service. Firefighters with a radio should be stationed at any closed control valve so then it can be reopened. Some departments will prefer to plug active sprinklers individually rather than close the fire suppression system's main control valve. This is done typically by wood wedges. They do make commercial devices for this that can also be utilized. The cheap and inexpensive way is wood wedges. A couple different types of control valves. You have outside screw and yoke, which you see in the left-hand picture here. And this is, you can see that you have the long threaded stem on your OS&Y, and you may also have a PIV, a post indicating, or it could be a WIV, a wall indicating valve, and it will look like the picture on the right. Here's your wall PIV, the wall indicating valve. Same thing as a PIV, it's just mounted on the wall basically. It'll have the open and closed window so you can tell whether it's open and closed. These are also most of the time electronically monitored with the monitor, and they are usually chained in the open position. And this PIV has an indicator on the top that lets you know that it is open or closed by the yellow wheel. Stopping the flow of the sprinkler, you can use a swivel type tongs, which is a commercially made device that goes in there, has a rubber seat on it, and it screws out to create pressure. And you can simply use wooden wedges as well. Next, the duties of the firefighters that are related to building utilities. Controlling utilities helps us control the fire, and it can limit the damage. The incident commanders or the supervisors make the assignments which have us control these utilities. We need to know location of control switches and or valves and how to shut them off. We do not want to attempt to turn utilities back on. We let the proper utility company take care of that. Maintain situational awareness with these utilities. Conditions to observe and to communicate is, one is the location of the services. As we do those 360 walk-arounds, note where gas meters, where power shutoffs, service drops are located. the status of the power, whether it's on or off, any damage that's been done to the utilities, either prior to the fire or because of the fire. We want to know presence and conditions of any FDC connections and any fire suppression systems that may be present. And then we want presence and condition of the standpipes if they're equipped. The location of any alternative utility sources as well. Electricity is one thing that we find ourselves dealing with a lot. It's electricity and water don't mix as well. And the big thing is when we start pulling apart walls, wiring is run into the walls, and we don't want energized circuits when we're pulling with metal hooks and getting into and breaking up walls and trim. So we need to disconnect this as quick as we can. It can be left on in large structures with multiple breaker panels, and then we just shut off zones. The structure may be total electric, or the electric may only provide for lighting. With commercial property power supplies, one of the big things that helps us with these properties is having the proper pre-incident survey, where these surveys should identify the location of the power connection. Then our main breaker or meter shutoffs is the only safe way basically to shut the power off. If the power will not shut off, or if the main breaker is not accessible to us, take no action, and then we'll contact the electric utility or the electric company. Typically, in most cases, we will call the electric company. We'll have them en route to shut down the utilities and pull meters. If we need it done prior to their arrival, we will try with the main switches first, and if that does not, then we will rely on them to complete the action. Again, a warning here, only use the main power shutoffs at the meter or breaker box to shut the electricity down to a structure. Further actions could result in electrocution and should be left to the utility company personnel. Typically what we have happen here and the questions that we get here are removing meters from meter bases. You have to be careful in removing meters, because if you don't get all the lugs taken out at the same time, you can cause an arc. You can cause a meter to explode, and they are like a grenade when that happens. And we got to realize that the electricity can arc, and it can arc up to 3 feet. So you really, if you're not trained to disconnect and remove a meter, then we shouldn't be doing so. With commercial power supply, the power should not be shut off until ordered to do so. The building may have high voltage and or low voltage systems involved depending on the equipment that they run. It could be HVAC equipment, it could be other equipment with processes, so we have to be careful about that. Lockout, tag out device, or leaving a firefighter with a radio prevents the power from being turned back on inadvertently. Something else that we have to think of these days is alternative energy sources. One of the biggest things is solar panels. And so we find these on roofs, we find them in yards, we find them in all different locations. And closing a solar panel master switch will shut off power in the structure, but it will not turn off the solar panel. So we want to avoid panels when performing ventilation if they're on the roof. Fires involving panels may have increased electrical hazard. Damaged panels should always be removed by a trained electrician. So these collectors, or these panels, are collecting energy from the sun and then changing that into a usable electrical energy. And so they're always collecting, and until they're completely disconnected, they're transferring power to either the power system or the battery system that they have. Remember that they generate current whenever there is a light source, such as moonlight, sunlight, or even artificial lighting, and they are always energized. Wind turbines is another alternative source of energy. These provide alternate power or power in addition to the power company. Turned off at the meter box with the main power shut off. If they're wired correctly, they should have a main power shut off. The power line from the wind turbine to the meter then will remain energized. Generators is something that is widely used, more so than the first two alternative sources that we talked about. And the generators are used when power service is interrupted, or it may be the sole power source at the time. Shutting off the generators should control the systems. If the generator supplements the power supply, shut off the supply at the meter box as well. When shutting off building utilities, do not assume that there is no alternative source of energy present. Always use caution and refer to local policy for further guidance. Next is natural gas. This is something that we deal with quite a lot on a regular basis. In its pure form, it is known as methane. The range of flammability is 5 to 15%. We know that natural gas is non-toxic. It rises and diffuses in the out and open. It can be an asphyxiant because it can fill up an area and push away the oxygen. Mercaptan is added to give a skunk or sulfur-like smell or odor in order for it so that it can be detected. The supply must be shut off at the meter. The shut-off is an inline valve. You can use a tool to turn the tang until it is 90 degrees to the pipe. It'll look like basically it's crossing the pipe. Then you know that you have it off. If that looks like it is in line with the pipe, then it is still on. If shutting off the valve does not stop the gas supply, take no further action and contact the gas utility. Fire departments are not responsible for turning the gas back on. And a safety note here, when you discontinue or you turn off natural gas at the meter, the gas company needs to turn it back on because there may be appliances that have pilots that need to be relit and checked and things like that. Again, a caution, natural gas that leaks underground and around wet soil can lose the odorant smell and may become more difficult to detect without instrumentation. Next is LPG, liquefied petroleum gas. Fuel gases that are stored under pressure. Propane is the most widely used, and under pressure it does become a liquid. Again, mercaptan is also added to propane so that it can be detected because it is a colorless and odorless gas as well. Propane is also non-toxic, but is and can be a asphyxiant. Again, if it fills an area, it can push away the oxygen that is needed to breathe. This, although, will sink to the lowest point possible, which is different from natural gas. It can be explosive in concentrations between 2 and 9.5%. Not as wide a range as natural gas, but wide enough. So this is usually stored in cylinders and tanks near the point of use. Steel piping or copper tubing that connect the cylinder or tanks to the appliances. Shutting the tank valve may stop the gas supply. The leak will produce visible vapor that hugs the ground. Fog streams of at least 100 gallons per minute can dissipate the gas cloud. Shut-off valves for propane. Do not open the valve after fire or an emergency is terminated. We want to leave our shut-offs shut down. Let the gas company or utility company then put things back in service. Next is water. Shutting off the water is another thing that we have experience with and may need to do. Shut-off valves located underground with the water meter, or they may also be inside the structure, such as the basement. The meter may also be in the basement. We want to turn the tang 90 degrees to the pipes. Again, it will, if it's in line, it is on. If it looks like it is crossing the pipe, then it is off. A word of caution, electrical ground wires may be connected to the water pipe, grounding wires. Commercial, industrial, and institutional structures require a water shutoff key. They may have a specialized key. Restoring the supply, again, is the responsibility of the water department or the owner themselves. Next is the process of attacking a vehicle fire. One of the things to note is we want to wear full PPE and SCBA during all operations with vehicle fires. And we often think of, why we're in the grayed out, we're in the open, but there are a lot of plastics, foams, rubber material that are burning in our vehicle and even the engine compartments. Very, very toxic gases are coming from this, and so you, just like in a structure, you can be exposed to it even standing around it. So it is best policy, wear all your gear. We may use portable fire extinguishers with smaller fires or even charged hose lines with bigger fires. Power sources of our vehicles, we're used to gasoline and diesel. Now with hybrids, electric cars that have a small gasoline engine that will let you start up and get going, and then once you're in the long haul, the electric takes over. There's total electric cars, CNG or LNG cars, biofuels, and even hydrogen powered cars now. With vehicle fires, we want to think about the overall scene safety. One of the first things that is on the list is traffic control. Uh, any traffic control, that's one of the most dangerous things anytime that we're operating on the roadways or the highways. We want to try to isolate ignition sources. Victim extrication may be a priority as well in the case of a vehicle accident. And you can use emergency moves at this point to remove somebody quickly. C-spine and those things are out the window. We want to control the fire and control any other hazards. We also want to avoid common injuries at a vehicle scene. Avoid components that may be under pressure. Um, Rear bumper struts, front bumper struts can be under pressure. Any of the struts on the hoods, trunk deck, hatches, those little gas-filled struts, again, are under pressure, and these are areas that we want to try to avoid. And we have to think about that when we're approaching. That's why we approach from corners and not, directly in front of or behind the vehicle. Controlling fuel leaks. Fuel leaks can come from broken fuel lines and or broken or punctured fuel cells. With the fuel lines, there's times we can crimp them down with pliers. A lot of your vehicle fuel lines are made of metal, and they can also be rubber flex at some points. You can crimp them down and stop the flow. You can plug with rubber, plastic, or other wooden type plugs as well. And with fuel cells, we can plug with a rubber, plastic, or wooden type plug or wedge, or you may seal the fuel resistant with a fuel resistant type sealing compound. Selecting our proper hose streams for the vehicle fire. With most vehicle fires, 1 or 2 1.5 inch or 1.75 inch hand line is going to be sufficient. With larger vehicle fires, you may consider 2.5 or 3 inch lines as well. Defensive techniques, deploying master streams and isolating and denying any entry. Bigger commercial vehicles that also may involve a tanker, vessel of fuel, something like that we may get into defensive techniques as well. I will say that vehicle fires can be one of the most fires that seems simple but can embarrass you pretty quick. Sometimes it's hard to get hoods up, as an example, and you get into this business of, I can't get the hood up, we can't get the fire out, fuel lines burn, into the plastic or the rubber ones, and then they start dripping fuel out on the ground, and you end up having to ultimately break out the foam pack to get things put out. Maintain flash fire protection. It's a good idea to have a secondary hose line as well. Approach from the corners, and keep in mind that your front being strictly in front of or behind can be dangerous positions because the gas shocks can swell and rocket off in an explosive manner. So the green areas here in this slide, it depicts the safe zones, and so this is how we want to approach. Also, you want to put out any ground fires that may, on your way and your approach, use an attack at this 45-degree angle. Try to position ourselves upwind of the fire as well. Extinguish fire that's near vehicle occupants. If they're still in, that's our priority. Issue an all clear when the occupants get out of the vehicle. Extinguish ground fires around and under the vehicle as you approach, and extinguish the remaining fire in and around the vehicle. So this is kind of our priority steps. Combustible metal components, we do apply water to cool the components exposed to fire. If they become involved, then we may apply large amounts of water to adjacent combustibles, or we may have to apply a Class D agent to the burning metal. Magnesium and aluminum are metals that burn, and they are commonly used in the engine compartments of vehicles, modern vehicles. So we do need to keep that in mind, and if they do begin to combust, it can be difficult to get them out. We may have to smother out. Hopefully we reduce a significant amount of heat, but we got to realize that some metals react with water as well, such as magnesium, and that at the point that they start combustion, it could be water could be a very difficult task for material to use as extinguished. We may need to break out our Class D type extinguishers to get them fully put out. Hazards during our vehicle attacks could be large capacity saddle or side type fuel tanks, such as we see on bigger commercial vehicles. There also may be alternate fuel tanks. Some pickup trucks have dual fuel tanks, if you will. Usually they're on the same side, but not always. Pressurized natural gas tanks or cylinders. These can be, and also propane. We do have propane and natural gas driven vehicles now. There are a lot of school buses on the road now that are also propane. And another thing that we have to think of is any hazardous materials that they may be hauling. Overhauling the vehicle, we do want to check for extension and hidden fires, much in the same way that we do with a structure fire. One of the priority things when we get a hood up and we get the engine compartment fire extinguished is to quickly disconnect the battery so we don't have any power issues. And then we want to cool fuel cells and try to keep them intact in any of the sealed components. Secure airbags as well. Engine compartment, trunk compartment fires are conventional methods to access these compartments. Could be using the release levers. Usually those are cable driven, and if they have not been damaged by the fire, this does work if we can get inside the vehicle, if it's not involved as well, as an example, and activate these. But it also can be a challenge, and so we want to cool the front of the car. We want to, again, keep in mind if your front and rear bumper struts attack or approach at that angle, that 45-degree angle. Remember where your safe zones are. You don't want to end up directly in front of it. If you do, you only want to be there for a limited amount of time. And we can work to get the hood up. Hoods can be problematic. Hoods can. Forcible entry methods to access these areas. You can pry with your Halligan or crowbars. You can remove metal around the key or the latch. as well. With trunks, you can punch out the lock, the cylinder lock, um, with the spike of the halogen, or drive it through it as well. You can attack from the side with an axe and lever open as well. Direct your hose streams under the car, and you may also even use a piercing nozzle, right straight down through the hood. You can use a power saw to cut the latching device there, cutting across the front of the hood. But again, be careful about putting yourself in front of the car, especially if the engine compartment is fully involved. Controlling fires after it's been open, direct hose string, grill, around your hood scoop, in and around the engine compartment. If you drive a piercing nozzle through the hood, the fenders, and the wheel wells, we be cognizant of hybrid and electric vehicles. We want to make a cut or an opening large enough for the hose stream so we can apply water, and pry an opening between the hood and fender and direct a straight or narrow stream within that opening as well. Piercing the hood of a hybrid or an electric vehicle could result in electrocution. So these are vehicles that we want to try to note what they are early on and be careful when we're dealing with really any part of them, whether it's extrication, whether it's fires. Uh, Fires within the passenger compartment, we want to choose the appropriate nozzle and the pattern, attempt to open the door or break the window if it's not already out, and attack the fire with a medium tight fog patterns. And I know in compartmentalized fires, as far as structures are concerned, we don't really teach the use of semi-fogs or full fog patterns, but in a compartment that you're not going to enter, okay, that you're not in, and you're working from the outside in and you use fogs, you can step away from the steam and allow the steam to do the work for you. With your suppressing undercarriage fires, as you approach, you can sweep across and begin to hit. You can put out all the fire that you can in and around a wheel well, and then kind of bank up, if you will, like an indirect banking motion, indirect attack, and shoot water up underneath there as well. Ultimately, we may need to get the engine compartment out. You may have leaking fuel or a fuel line that has burned. Again, alternative fuel vehicles can be LPG, liquefied petroleum gas. They could be CNG or LNG, or natural gases, and we've talked about those a little bit. And then ethanol. Uh, you're already, with the gasoline used today, you're already at potentially 10% ethanol, but there are vehicles that run on solely ethanol. And the flash point is less than negative 5.8 degrees, and it goes all the way up to negative 21. So ethanol and alcohol vaporizes it. It's a little harder to see. It burns a clear bluish color as well. It can be fatal if swallowed, or it enters the airways, and we may it can cause eye irritation as well. It can be absorbed through the skin, and extreme exposure may cause unconsciousness or asphyxiation. Biodiesel is another one that comes up. It does, again, burn with a clear flame. It can be an irritant if inhaled. It can irritate your nose and mucous membranes, cause headaches. Visual indicators and fuel logos may indicate the presence of these alternative fuels. Usually they will have logos on them that say hybrid, electric or hybrid, hydrogen cars. The one that may not have anything are biodiesels, and that's people that have taken their own personal vehicle, make their own biodiesel fuel, and then they burn it in a diesel pickup truck. There may not be an indication that biodiesels are being used. There's no national requirement in the United States or Canada for the markings to indicate the type of fuel used to power cars, trucks, or buses. And because of this, you may have no idea about a vehicle's fuel source. Some states do require or may regulate the markings. Again, there may be no visual indicators that a vehicle is using an alternative fuel source. Natural gas vehicle fuel, CNG and LNG. The fuel tanks are usually in the trunk area, under side panels, or in the bed of pickup trucks. The cylinders can rupture if exposed to fire. They can levy just like a grill cylinder or any other LP cylinder can. Pressure relief valves and devices and vent and fuel shutoffs may be located in the wheel well area with a placard nearby. CNG is stored under pressure as well. With these type of vehicles, there may be no visible fire. You may have to use gas detection to locate leaks, locate shutoff valves, and eliminate any ignition sources and stay clear of any vapor clouds. We would approach it much the same as a gas leak. We may be wearing our SCBAs the entire time and using monitoring equipment. With visible fire, allow the fuel to burn itself out. We would use water or foam to extinguish as necessary, cooling the container from safe distances, keeping that from an explosion from occurring. Use fog stream to disperse any vapor cloud and avoid contact with high velocity jet or escaping type gas. LNG is stored in liquid state in double-walled vacuum insulated pressure cylinders. It is lighter than water. The vapor cloud is heavier than air, so it will sink much like propane. Frost on the fuel tank exterior indicates the tank it's leaking out rapidly and it will frost up. For no fire or leak, stabilize the vehicle, setting the emergency brake, chock the wheels, which we're carrying now, additional wheel chocks. Turn off the ignition and shut off the gas cylinder at the shut-off valve. Fires or leaks, we avoid contact with the material, the escaping material. Stay clear of the vapor clouds. Shut off the ignition. Purple K dry chems or high expansion foams may be used on the surface, and you may also use sand or dirt to prevent LNG from entering storm drains. Liquid nitrogen gas is it's not as common used as propane. LPG or liquefied petroleum gas is what we use the most, what we see the most. It's out there on the road. We know it is and call it propane. It's the third most common type of fuel, and it may be marked with a logo. As far as detecting the leaks, we use gas detectors to determine and isolate those leaks and ignition. So we want to get rid of any ignition sources, allow the fire, if present, to self-extinguish. You may use foam or water when necessary. Direct our streams at the top of the cylinder and to provide the cooling of the cylinder to keep an explosion from occurring. Stay clear again of any vapor cloud. Electrics and hybrids should have a visible indicator on the front or the side of the vehicle. The batteries may be in the engine compartment, trunk, or under the vehicle. There may not be any engine noise at all. Most also contain a separate 12-volt battery system for small things on the vehicle. So the locations of the batteries again may be in the engine compartment itself. A lot of times you do find them under the trunk, and then with some makes and models they are under the vehicle and protected. Dealing with vehicle fires of this nature, a lot of times there's no visible fire, or in the case that there's not, we want to secure the vehicle. These are the vehicles we want to chock the wheels, turn off the ignition, or remove the key or the key fob from the area. When we have visible smoke, full PPE, SCBA breathing air is required until the air monitoring indicates that the atmosphere is clear. any fire or arcing, be careful and do not approach the vehicle. Establish your scene security and protect any exposures. Avoid contact with all fluids. Hybrids or electric hybrids, the batteries must be recharged periodically. Many types and designs and locations of battery packs are out there. Technology, we've gotten really good at lithium ion and other types of battery packs. So and with these cars, most of them are encased very well, uh, and protected very well. Inertia switches and pilot circuits are used to shut off the high voltage systems. So if they were to roll over, they'll automatically shut off. If they're on their sides or tops, they'll shut off. Um, it takes approximately 5 minutes for the energy to totally dissipate. Um, Remember to not cut orange, blue, or yellow cables. They are high voltage cables, and cutting into them can be dangerous. Wear full PPE. Use insulated tools, any water or foam to extinguish, and specifically recommended extinguishing agents for battery pack type fires. Here's a battery pack that's located in the front. It's rather large. Though they're marked, but you can see how well cased that is. Ethanol and gasoline blends with ethanol. Water soluble, electrically conductive clear liquids with slight gasoline odor. Some fuel tanks, as conventional gasoline engines, it'll have the same type of fuel cell, and the vehicle may not have any visible logos on them. With no leaks or fire, secure the vehicle, chock the wheels, turn the ignition off. If we suspect a leak, then full PPE, SCBA, deploy our charged hose lines and begin, detection process. Leaks or fires, establish your control zones, hot, warm, and cold. Request hazardous material teams and approach it in that manner. Biodiesels, again, these are blends of liquids made from natural plants and diesel. Usually a yellow liquid with odor of cooking oil. So what folks do, they'll make their own biofuel, and they'll take used cooking oil from restaurants who use a lot of cooking oil. And what they do is they will filter, refine, and then add chemicals to it, and even mix with a certain amount of diesel fuel and make it usable. So they'll burn this for fuel. It is slightly lighter than water. The flash has a flash point of 266 degrees Fahrenheit, and this is used in vehicles designed for diesel fuel. No logos are required. A lot of folks that are dealing with biodiesel are individuals who are trying to save money on diesel fuel. With a fuel leak, we want to control leaks per SOP with diesel, like we would control a diesel fuel. We may also, depending on the amount of product that we're talking about, maybe request hazardous material teams as well. With a fire, use dry chem, CO2, water fogs, or foams to extinguish. Hydrogen is another alternate fuel source that is out there. It is in use in some areas, but most vehicles are still in the concept stage with the hydrogen type fuel. It is colorless, odorless, non-toxic, and energy efficient. The ignition temperature of 932 degrees Fahrenheit, which is fairly high. Flammable range between 4 and 75%, which is very wide, and it does produce an invisible flame. Use a thermal imaging camera during the day if possible. Vehicles marked with manufacturer logos, vented fuel cells usually are found in the trunk. We want to shut the ignition off if at all possible. Isolate the fuel from ignition sources. Chock the wheels. Do not extinguish the fire and allow the fuel to burn off. Protect any exposures. Do not cut C-post if extrication is required. This is something that's important because a lot of times when we're removing roofs, we may end up cutting a C-post. And if we if we don't want to cut into a C-post, we may V-notch it at the top of the roof and leave the full length of that post. Next is the process of attacking fires in exterior Class A materials. This could be debris piles of stacked and piled materials, brush, leaves, things like that, small unattached structures, or even trash containers or dumpster fires. They can be a hazard to nearby structures. Flammable and combustible storage tanks can be endangered vehicles and then just simply the vegetation. The extinguishment is going to depend on the type of material involved, the weather, and the type and quantity of extinguishing agent used. Again, maintain your situational awareness with these type of fires. The conditions to observe and communicate are any changes to the configuration of the materials, especially if it's piled up, changes to the firefighter position, to the fire based upon changes to the spread of the fire, indicators of imminent collapse, spread of fire to exposures, wind direction and speed, which is something we should always be thinking of in the outdoor fires, and effectiveness of the attack. Are we fronting a good attack, and are we causing extinguishment? With stacked and piled up materials, raw materials such as you find at sawmills, lumber yards, and manufacturing facilities, when we have fires in these, this can just be a nightmare. It's like a bale of hay. You almost have to get it all spread out before you can get it out. Bales of cardboard and pallets may be near in retail outlets. This is common. Baled up cardboard is having fires, and these are common. Uh, Rolls of hay and cotton at farms also, especially if they were rolled a little too wet and they spontaneously combust. Uh, Loose materials such as mulch, fertilizer, or at nurseries and garden centers can be issues, and any miscellaneous materials stored outside. Stacked material could be possibility of salvaging materials once the fire starts is small. We get it put out quickly. The greatest danger is the exposures, and the goal is to confine the fire to an area in origin and get it put out. Use your straight stream from a distance. Then we may shift to a fog pattern. This is another example that fog patterns work well. Remember, when you're using these fogs, you are in the outdoors. You're not in a compartment or a confined area. Once the fire is reduced, move the nozzle closer using your fog patterns, and that fog pattern will even protect you. Break up or pull apart the material with pike poles as we go along. Remember, with stacked and piled up materials, we could have a collapse danger, and we can also have a danger of flying embers. Class A foam applied with an eductor or from a CAF type system is very effective. So this is an area where our Class A foams that we're carrying on our apparatus are effective. Outbuildings, storage sheds, small unattached structures, if you will. This is our sheds, outhouses, pump houses, ice houses, bath houses, you name it. Um, these small unattached structures, we want to attack from the exterior, prevent spread to exposures, then extinguish the fire. Again, Class A foams and fog screens can be effective in advancing close to the fire. Apply a straight stream from the exterior to extinguish the most or the bulk of the fire. Assume that chemicals, flammable and combustible liquids such as gasoline cans and things like that, maybe even explosives or illegal materials could be present in these outdoor storage buildings. If there is any question of hazards, protect exposures, prevent the spread of the fire, and allow the structure to self-extinguish. Again, a word of caution is chemicals used in the production of some illegal drugs are extremely toxic and volatile. Incidents involving them may require the assistance of law enforcement personnel and trained hazardous materials personnel. Trash containers. Trash container fires may have toxic products of combustion. Um, this is one that full PPE and SCBA is required. Refuge may include anything. It could be hazardous materials. It could be plastic, aerosol cans, batteries, which you're not supposed to dispose of in regular trash. And these things can explode. Biological waste can be present as well. Once the fire's been controlled, it may be possible to do standard overhaul, but just remember when you're doing overhaul in trash, use your pike poles and your rakes because shovels because don't use your hands because you can put your hand down in biomaterial, sharps, stick yourself, all kinds of different things. We don't know what people are throwing away in their trash and how they are containing it. Class A foams may also help. Some departments use master streams to flood containers. You're just kind of lobbing, a lot of water basically in a dumpster and you would fill it up. And this does work. Next on our list is ground cover attacks. This could be weeds, grass, brush, and up to forest fires. The main influences that we have on fire behavior, one is fuel. One of the big things is weather and the topography. Ground cover fires can be deadly to firefighters even if they are working in very light fuels or working during the overhaul phase of an operation. Situational awareness with ground cover fires. Conditions to observe and communicate. Topography, weather is the big thing. Fire behavior, and we want to constantly monitor for erratic fire behavior. Escape routes, location of our resources, and the characteristics of the fuel. Are we in light fuels? Are we in 1 hour fuels, 2 hour fuels, 10-hour fuels, so on and so forth. Three types of fires: ground fires, surface fires in your smaller brush and shrubbery, and crowning fires. We don't see crown fires a lot in Kentucky, but they are possible depending on how dry the season is. Fire behavior for the wildland setting: oxygen and fuel are always present. Okay, natural or human-made ignition source. That's usually what happens, but it can be natural as well. Lightning strike is an example. And then you'll have the result of materials catching on fire. And these are Class A materials. We could have the crowning fuels, the aerial fuels, surface fuels, and subsurface fuels found in the duff. Factors that affect these type of fires, again, the fuel size. One of the big things is the moisture content, and that's why as the day goes along, these fuels will lose moisture content and they will become, unless you're on the north side, they will become more combustible. And then as the dew falls again in the evening time, we'll hit another time frame where they gain moisture content. The compactness, the volume, and the continuity or the arrangement of these fuels as well are characteristics. Factors in the weather: one is wind. A wind-driven fire can be very violent. It can be very difficult to control. The temperature, when it's hot out and it's dry and everything is the moisture content is easily dried out, the difference in those temperatures. Relative humidity, how much water is in and vapor is in the air, and any precipitation. We consider topography, especially on the slopes, because the steepness of the slope can accelerate fire spread. What you will have is you will have a preheating, if you will, of the fire materials. You'll have a preheating of it, and as it moves up the slope, it will preheat what's above it and that will cause that to catch faster, so on and so forth. Moving down the slope, it would be slower because the tendency is the heat rises up the slope. The aspect, which is the side, whether it's north, south, east, or west, we know the north side has more moisture content. The local terrain features, any drainages or areas with wind flow restriction. And we have to remember that drainage and canyon type areas um, can really cause an accelerated fire that burns up through them. So the anatomy of a wildland fire, we have the heel of the fire where the origin is. It starts and it will begin, it'll burn up and away, usually in the direction of the wind. The right and left flank, which could be right side, left side, you may see branches out ahead in the direction of the wind called fingers or the head of the fire. And you may, in very windy situations, you may see spot fires. What we need to remember about this is this can change. So you imagine the blue arrow there. If the wind direction changes, what's going to happen? Your right and left flank's going to change. Your head and your fingers are going to change. Perimeter control, we do so using a control line. This can be established at the burning edge, next to it, or a considerable distance away. Basically, we are taking away and raking down the vegetation to mineral soil, and we're taking away the fuel, basically. The objective is to encircle the fire by doing this with all the fuel inside that line or that circle, if you will, burning away. Ground cover fires can be attacked directly. You can lay wet lines and you can also use a pump and row technique as they're doing in the picture on the left hand side of the slide. On the right hand side is creating control line. They're raking vegetation away down to the mineral soil and removing the fuels. Our goal is to circle with control line, whether we're plowing the line, whether we're hand raking the line, and the fuels will burn out to the brake. And then our goal is that the brake is wide enough, the control line is wide enough that it doesn't jump that line. And the fire goes out. Our fire lines, we want to remove all vegetation debris, clear all the way down to the mineral soil. Widen to provide a sufficient brake. We want to throw all burned charred material into the black. The black is actually already burned. Scatter all cut and unburned fuels into the green and remove all branches that hang over the line. Lookouts, communications, escape routes, and safety zone. This acronym we use is called LCES. This helps us remember these four things. With our lookouts, know where you are, where the fire is going. Communications, we want to know who is operating above, below, adjacent to you. We always want to know more than one way out or escape routes within the zones that you're working. And we want to know how to quickly get to our safety zones. This is an area where there's no fire or danger. Non-fire hazards could be unstable trees, rotten trees, trees with branches that are ready to fall out. Other non-fire hazards could be animals, snakes, insects, you know, extreme temperatures, and any electrified fences. Power lines is a big one. We want to, what caused this fire? Did a down power line cause it and it energized a fence that is woven wire or metal? These are things you need to consider in your situational awareness. Explosives may be present, especially on farms and construction sites. Any hazardous materials. You may have propane cylinders in backyards, things like that. Rolling or falling debris, such as on hillsides. We got to watch out and be cognizant of pits or shafts, sinkholes. and even animal traps. People live on farms, set traps for animals such as coyotes, and we can get into those as well. Be aware of the weather. Anytime that we're dealing with wildland firefighting, weather is the big thing. First and foremost, we need to get the weather report, and we need to maintain on-site weather. That's having our little handheld machines as well as getting a report from the National Weather Service. Do not stand under tall and isolated trees. Always have your headgear on. Stay away from open water, metal objects, equipment, or wire fences. Find suitable shelter when we're dealing with storms and lightning. Monitor our stress levels, check heart and lung rates, stay hydrated, and use rehab facilities. The big thing is hydrated and check on one another to make sure that we are not exhausted and that we're staying hydrated.